Madam C.J. Walker, born in 1867, was an African-American entrepreneur, philanthropist, and political and social activist. She developed a line of cosmetics and hair care products for black women in the early 1900s. Walker is recorded as America's first female self-made millionaire in the Guinness Book of World Records.
Hi, boys and girls. My name is Dr. Carol, and I am a chemist, and today we're going to do a little chemistry. Specifically, we're going to do some experiments about dissolving things. Now, dissolving things is when you put a solid in a liquid, and pretty soon the solid, it looks like it disappeared. Like if you put sugar into water and it looks like it disappears, well, what really happens is that all the little sugar molecules separate from each other and mix in very, very completely with all the little water molecules. So it looks like it disappeared, but it really didn't. It's still there. And sometimes it looks like it melted, but it didn't, because if you then dried all the water off of it, you'd see the sugar would still be there. So it's not like an ice cube. It's not melting like an ice cube. It's just dissolving. So today we're going to do some dissolving. And I'm going to start with a styrofoam cup, plain old styrofoam cup. Okay. And I'm going to see if I have a way to dissolve this. Okay. So what I'm going to do, I'm going to let's start with water. Is water going to dissolve a styrofoam cup? I doubt it, because we use styrofoam cups to drink things like water. So let's see. Is that dissolving it? Is anything happening there? I don't really see much of anything happening. So I don't think water is going to dissolve styrofoam. Okay, so let's try something a little bit stronger. And if you've done some experiments at home, you've maybe used this before. Can you see it? It is white vinegar. It's vinegar. And we do a lot of kitchen experiments with vinegar because it does some pretty interesting things, especially if you mix it with baking soda. So that's a little stronger than water because it does interesting things with some things, but I wonder if it's going to dissolve my styrofoam cup. Let's try. All right, I'm putting my vinegar in there. And let's see, is that dissolving anything? I don't really see any. I'm not seeing much of anything happening here. Well, I guess vinegar is not strong enough to dissolve styrofoam. Let's try something else. I'm going to rinse out my cup. And put the cap back on my vinegar. And now we're going to try something else. And this is, can you see that? This is nail polish remover, okay? And nail polish remover has a chemical in it called acetone. And acetone is really good at dissolving things, really good. And, this is nail polish remover, which you can think about. If you have nail polish on, which I do not, but if you have nail polish on, what you do with the nail polish remover is you're dissolving the nail polish so it goes away. And it ends up on your cotton ball. But that's because nail polish remover has something called acetone in it, and acetone is a very good solvent, they call it. It dissolves things very, very well. So let's see. This is going to be interesting. Let's see if nail polish remover with acetone, I'm getting a shadow on my face, nail polish remover with acetone, let's see if that will dissolve our styrofoam. Here we go. Let's see. Well, not much yet. Ooh, it's feeling a little softer there. It's a little softer. Let's see. Ooh, it's getting much, looky there. Look at that. It's starting to drip out because it dissolved it. Look at that. It dissolved it. Oh, that is really cool. Okay, see, and look at this. Oh, maybe you can't see this. I'll get it a little bit out of the light. But see, it poked a whole big hole in it, right? Oh, goodness. And now I think the whole bottom's going to come out. Ooh. So acetone, the nail polish remover, dissolved that styrofoam. So that was pretty interesting. But let's try something else that might be even more exciting, okay? And I'm going to rinse this out. I have a bucket down here to get my rinse water. Okay, so now let's try that again with another cup, another styrofoam cup, but now we have something that's stronger. And let's see if you can see that. This is pure acetone. Pure, you get this from the beauty supply store, and it is stronger than the nail polish remover. Sometimes if you have certain kinds of nail polish that don't come on, that are tougher. So this is stronger. This is pure acetone. The nail polish remover is diluted a little bit. It's got a little bit of water in it, okay? So let's see if the pure acetone, now if this is stronger than the nail polish remover, do you think it might dissolve things faster or slower? What do you think? I'll give you a minute to think about that. And then we will do our experiment. Okay, so I'm going to put some of our pure acetone in our styrofoam cup. Whoa, I can hear it fizzing. It's fizzing. Oh, that was quick. Look at that. I don't know. Oh my goodness, look how floppy that's gotten. That is all floppy. It's just, yeah. Ooh, look at that. That's pretty cool. I can stretch it. Things you can't do with a styrofoam cup. Look at that. Oh, how cool. Okay. Now now I'm going to get a little bit chemical on you. What is styrofoam? Styrofoam is made of a plastic called polystyrene. Okay, so that's where the styro comes in styrofoam. So it is it's polystyrene. Oh my gosh, look how much that smashed up this cup. Oh, that really dissolved it. So polystyrene is a kind of a polymer, kind of plastic, but in styrofoam, what we have here is the polystyrene, but with bubbles mixed in there. It's what they call expanded. It's you melt down the polystyrene and then you blow some air through it and you end up with bubbles inside the plastic, and that's where they get the foam. So that's why it's styrofoam, okay? But then once we have dissolved it, that opens up all those bubbles, and what we're left with is just the styrene. So this is the stuff I just pulled out, and see, it's not as floppy. Certainly when I did it before, I could stretch it really easily. It's not as floppy as it was, and we're going to let that dry a little bit because while it's still got the solvent in it, the acetone, it's going to still be a little floppy, but oh, look at that. See, now it's stiffer. Okay, it's much stiffer because that is just pure styrene after we've gotten rid of the air that's inside the styrofoam. Okay, so that's pretty cool. I like that. Okay, so I did rinse this out. Okay, now this is the part I haven't tried before, so we're going to do an experiment where I don't know how it's going to work out. Isn't that exciting? Okay, so the thing is that styrofoam is one way that polystyrene is used, and it does a good job of insulating it. So most of the time you will use I wouldn't use that cup, but you would use one of these kind of cups for a hot liquid like coffee or something so that it doesn't burn your hands, okay? But there are other ways that polystyrene is used, and this is a red Solo cup. And I think most people have seen red Solo cups. But if you look at the bottom of a red Solo cup, and I don't know if you're going to be able to see this, but if you look at the bottom of a red Solo cup, let's see if I can get this You might be able to see this. See how it's got the triangle with the arrows? And that usually means it's for recycling. It's to let you know if something is recyclable. And this has a 6 in the center. That's the part I don't think you can see. And PS underneath. Because this, and see, this is stiff. This is much stiffer because this is pure polystyrene, okay? So if acetone dissolved styrofoam, do you think acetone is going to dissolve pure polystyrene? I'm going to guess that it will, but it might take a little bit longer. So let's try. Here I am doing an experiment where I don't know how it's going to work out. This is exciting. Okay. I'm putting my pure acetone in my pure polystyrene. And let's see. Well, I'm not hearing fizz. I think the fizz before was because those bubbles were coming out. That was what I heard. Let's see. Are we getting anywhere? I'm just going to let this go for a little while. Oh, I think it's starting to get a little soft. This is going to take a little bit while because when you have these bubbles, see, dissolving things only happens at the surface of the solids. So if you have little sugar crystals, the dissolving only happens at the very outside of each one of those crystals. But once it starts, it goes pretty fast. And so with the styrofoam, because of all the bubbles in there, there's a lot of surface of the polystyrene that's around those bubbles. And so that's going to happen a lot faster. This is starting to, let's see, I have another one. Let me compare. Okay. I can feel how squishy that is. And this is, there it goes. There it goes. Look at that. Oh my goodness. Yep. So our acetone was able to dissolve pure polystyrene or solid polystyrene or polystyrene that doesn't have the bubbles in it. And so, but it took longer because there's not as much surface area for this cup as there is in this cup. So that is dissolving things. Wasn't that kind of fun? So I hope that you will enjoy all of the science videos that the Delaware Children's Museum is putting together. I'm Dr. Carol, and it's been fun doing some experiments with you. Bye-bye.